right, today's topic, function operations with the crazy cat lady, Mrs. Peters of Hiram High School. A function is normally written in the f of x notation here. Okay, quite often we refer to functions by their name. And in this case, this one's called Fred because he starts off with f. Now, sometimes I might write a function as g of x, 3x plus 4. I can call that one George. George and Fred are exactly alike. Now, if I come in and I changed 4 to be 5, now George and Fred are no longer alike. So we can use function operations. Okay, this is h of x, and let's make him negative 2x plus 8. And what I want you to remember is that we can call our functions. This is our information telling us that our functions have different names so that we can talk about them and not have to write the whole function out. That we can just refer to them by their short name, in this case Fred, George, or Grover, and Harry. The next thing I want to talk about is adding two functions. And I have two functions already listed here. I have Fred and Grover. And we're going to write. Okay, now, quite often we would write that I'm going to add the two functions. And this is the notation that you would see. I'm going to take Fred, and I'm just going to take this part here. And I'm going to take Grover, and I'm just going to take this part here. And I'm going to add them. I'm going to use a set of parentheses. Okay, remembering that this is just the name of my functions. So Fred, which was 4x minus 7, I'm going to add Grover to him, which was 10x plus 9. Now, just like in adding in polynomials, all we're going to look at is we're going to remove the parentheses, just like we would if we were adding polynomials. So I have 4x minus 7 plus 10x plus 9. I'm going to combine like terms, right? 4x and 10x is 14x. Then I'm going to take these terms, these are called constants, they have no variables, and negative 7 plus 9 is positive 2. So the answer to f of x plus g of x, this part here, is actually 14x plus 2. Now, let's look at what happens when I am going to be subtracting two functions. I'm using the exact same two functions, Fred and Grover. I like Fred. He's nice, Fred and Grover. And we're going to write it in a similar manner. We're going to refer to it as f of x minus g of x. Okay, I'm going to write Fred in. Fred was 4x minus 7. And Grover was 10x plus 9. Now, we have to be very careful of this subtraction symbol here. Okay, we have to distribute that subtraction symbol into both parts of Grover. So, with that said, I've got 4x minus 7. No distribution needed there. Minus 10x minus 9. I'm going to collect like terms. 4x minus 10x gives me negative 6x. Negative 7 plus negative 9 is going to give me negative 16. So f of x minus g of x is equal to negative 6x minus 16. What I want to caution you in is that this is not going to give you the exact same answer as if we did Grover minus Fred. So let's look at Grover minus Fred. So that would be g of x minus f of x. Okay, put my parentheses in. Okay, Grover was green, so we're going to use green. Grover is 10x plus 9. Okay, Fred was red, so that would be 4x minus 7. I still have to distribute that negative sign in. So what I get is 10x plus 9 minus 4x plus 7. Okay, I'm going to combine like terms, so I get positive 6x, and I get positive 16. So g of x minus f of x, very similar numbers in this particular case, but signs matter, because last time I looked, negative 2 is not the same place on the number line that positive 2 is. So it really does make a big difference. Now, we're going to go talk about multiplying two functions. And again, I'm using Grover and Fred. Right, so I'm going to write this f of x times g of x, okay, means I have, remember, two sets of parentheses together means I have multiplication in between them. So, Fred is red, 4x minus 7. Grover is green, and that is 10x plus 9. Now, some of y'all don't remember how to multiply. Don't worry. I like using the box method. I'm really partial to the box method, actually, and I'm going to show you how to do the box method. I'm going to draw a box. That's why it's called the box method. Okay. I'm going to divide my box. I'm going to put Fred on top. So this is 4x, negative 7. I'm going to put Grover on the side, which is 10x, and positive 9. Now I'm going to actually do multiplication. Okay? 10 times 4 is 40, and I have x squared. 10x times negative 7 is negative 70x. 9 times 4x is 36x. And 9 times 7, let's see, that is 63. Okay. Now, what I'm going to do is I'm going to go ahead and write down all those lovely terms. I have 4x, 40x squared minus 70x plus 36x plus, excuse me, that should be minus 63. Minus 63. I'm going to combine like terms. The only like terms I have is negative 70x and positive 36x. Let's see, that's going to give me 34. 34x, negative 34x, 40x squared minus 63. So f of x times g of x is this lovely polynomial of 3 terms. Right? The last thing we're going to talk about is dividing two functions. We're going to talk about Grover and Fred, okay? And I'm going to write my division as a fraction. So I'm going to say f of x divided by g of x. Okay, well, that means I have 4x minus 7, that was Fred, over Grover, 10x plus 9. Doesn't simplify, they have no common factors. I'm done. There's my answer. Now, just like with subtracting functions, f of x divided by g of x is not the same thing as g of x divided by f of x. So let's look at this. Let's go. Okay, g of x divided by f of x. You know, and I sort of missed out on doing those colors. So Fred is red, and Grover is green. And it didn't choose to make it green. How about that? So they have no common factors. It doesn't simplify. I'm done. And that is, in a nutshell, function operations. Adding, subtracting, multiplying, and dividing. You can do it all. It's just like polynomials. It just looks scary. You can do it. I'm proud of you. Talk to you later. Bye.